From Planet Earth by Christine Taylor Butler. Above and below. Below us, our planet is composed of 4 main layers. The outer surface is called the crust. Beneath that are the mantle, outer core, and inner core. Circling overhead is a layer of gases that forms our atmosphere. Each layer plays an important part in Earth's ability to sustain life. For example, plants and animals depend on liquid water on Earth's surface to drink. As a gas, water can travel on winds to fall on places around the world as rain, snow, or hail. Earth is the only planet in our solar system where water exists as a solid, liquid, and gas at its surface. The crust. Earth's outermost layer includes the continental crust and oceanic crust. The crust and the uppermost layer of the mantle are broken into sections called tectonic plates. The plates rest on top of a more fluid layer of mantle and are constantly moving. Scientists believe Earth's continents were once joined as a single landmass called Pangaea. Over millions of years, the tectonic plates shifted. This caused Pangaea to break into sections. The sections drifted apart and formed the continents we know today. Earth has 7 major plates and many smaller ones. Tectonic plates sliding against each other can cause mountains to rise along Earth's surface. When tectonic plates slide over or past each other, an earthquake can occur. Sometimes the pressure causes shifts in the oceans. If the ocean earthquake is strong enough, waves can develop into a deadly tsunami. The collision or constant pressure of tectonic plates can create mountain ranges. For example, the Himalayan mountains in Asia grow taller each year. Water on Earth circulates constantly through the water or hydraulic cycle. Liquid water on the planet's surface is heated by the sun and turns into a gas. This gas, called water vapor, rises into the atmosphere. It gathers into clouds and falls back to the ground as precipitation, such as rain or snow. It collects in bodies of water or soaks into the soil. Then it starts the process over again. The movement of water is shown in blue arrows in this diagram. The mantle. Earth's mantle is a semi-solid and movable layer of rock. It is composed of silicon, oxygen, iron, magnesium, and aluminum. Sometimes this substance rises through the crust above. It surfaces as a volcanic eruption of molten rock. Islands such as the Hawaiian Islands were created as molten rock rose up from the mantle through the crust beneath the ocean. Scientists believe the mantle is about 1,860 miles, 2,993 kilometers, deep. This calculation is an estimate. No one has ever drilled deeper than 1.4 miles, 2.3 kilometers, beneath the ocean or 8 miles, 13 kilometers, on land. The core. Earth's core has 2 layers. The liquid outer core is composed mostly of iron and nickel, and is about 1,400 miles, 2,250 kilometers thick. It is constantly flowing. Its movement around the inner core creates Earth's magnetic field. Enormous pressure and radiation keep this layer hot. The inner core is solid iron. It may spin faster than Earth's other layers. The whole core is estimated to be 11,000 degrees Fahrenheit, 6,000 degrees Celsius. Earth's core may be as hot as the surface of the sun. A layer of protection. Earth's atmosphere wraps the planet like a blanket of insulation. Its 2 lowest layers are the troposphere and the stratosphere. More layers of thinner and thinner air are above the stratosphere. The troposphere is about 7 miles, 11 kilometers high. It contains the air we breathe. It is 78% nitrogen, 21% oxygen, and 1% other gases. Nearly all of the weather we experience on Earth occurs in the troposphere. This illustration shows the 5 layers of Earth's atmosphere. The stratosphere is about 30 miles, 48 kilometers high. It contains less water and more ozone than the troposphere. Ozone blocks harmful rays from the sun. The stratosphere and the layers above it also help protect us from objects in space, such as meteoroids. These objects sometimes threaten to crash into Earth. However, a meteoroid creates friction as it moves rapidly through the atmosphere. This usually causes the object to burn up. Falling stars are actually meteoroids burning up in the upper atmosphere. Meteoroids rarely make it to Earth's surface. If they do, the chance of them causing harm is very low. Which way is north? A compass needle points to Earth's magnetic North Pole. But did you know that the magnetic North Pole is not located at the geographic North Pole? The magnetic pole drifts about 6 to 25 miles, 10 to 40 kilometers each year. The north and south magnetic poles sometimes switch places. When this happens, Earth's magnetic field temporarily becomes twisted and scrambled. But this has only happened 170 times in the last 80 million years. After the next switch, a compass needle that would have pointed north will point south. The big truth. Dividing time. Earth is divided into 24 standard time zones. Each time zone is 1 hour ahead of the zone to the west of it. For example, say it is 12 p.m. in Anchorage, Alaska. At that same moment, it is 1 p.m. in Los Angeles, California. Most areas have adopted these standard time zones, but there are some exceptions. China crosses 3 standard time zones, but the country decided to have only 1 time zone. Some regions divide time zones by half hours. Iran, Newfoundland and Canada, and parts of Australia are examples. Map locations. 1. Anchorage, Alaska, 12 p.m. 2. Los Angeles, California, 1 p.m. 3. Newfoundland, 5:30 p.m. 4. Iran, 12:30 a.m. 5. China, 4 a.m. 6. Central Australia, 5:30 a.m. Mission Earth. Technology has come a long way since the days of ancient astronomy. Satellites create detailed images of Earth from space. Probes deep inside the Earth and in the ocean monitor the health of the planet. Global Positioning System, GPS, satellites allow us to navigate the planet without having to study the stars. Now scientists can spot problems and react quickly to natural disasters. This helps reduce the devastation the events could cause. A GPS satellite completes 1 orbit around Earth every 12 hours. The undiscovered deep. Oceans are one of Earth's most abundant resources, but only 5% of the ocean floor has been explored. That is changing. The National Oceanic and Atmospheric Administration is studying deep water canyons off the coast of Virginia. There, they use remote-operated vehicles, ROVs, and sonar. Woods Hole Oceanographic Institution uses a human-occupied vehicle and other underwater machines to explore and map even deeper waters. These missions help explain Earth's geologic processes. The Japanese vessel Shikyu holds the world's record for deep ocean drilling. To the center of the Earth. The exact nature of Earth's mantle is still unknown. To solve this mystery, scientists are hoping to drill directly into the mantle and take samples. Geologists plan to drill through a section of the Pacific Ocean floor estimated to be less than 4 miles, 6.4 kilometers thick. Special drills are being designed to handle the stress of boring through the hard oceanic crust. This $1 billion project is planned to start drilling in 2020. Exploring Earth's mantle through volcanoes. Antarctica's Mount Erebus is one of Earth's most unusual volcanoes. It is largely covered in ice, but it contains a lake of molten hot lava deep inside its crater. Scientists at the McMurdo Station Research Facility analyze the gas and lava produced by Mount Erebus. The data helps explain how and why volcanoes erupt. It can also tell us a lot about the mantle's chemical composition. A scientist uses specialized equipment to study the crater at Mount Erebus. Mount Erebus is so popular it has its own Facebook page. Destination Space. Human-made satellites also help us study Earth. The Aqua satellite was launched in 2002. Aqua uses microwave technology to see through clouds and monitor Earth's water cycle. For example, water and ice from melting polar caps could shift ocean currents. Weather would change, and Earth's temperatures could plunge. Other satellites look for activity signaling earthquakes, tsunamis, or other natural disasters. Satellites can track storms or changes in Earth's climate. The Aqua satellite is a joint project between the U.S. National Aeronautics and Space Administration and Japan's National Space Development Agency. To learn how things work in a weightless environment, world scientists designed the International Space Station, ISS. ISS welcomed its first astronauts on November 2, 2000. Since then, more than 200 scientists and engineers have visited the station. They have conducted more than 400 experiments. As of 2013, ISS completed more than 57,000 orbits around Earth. ISS orbits 240 miles, 386 kilometers above Earth. Exploration continues to expand. People once thought Earth was the center of the universe. What will we discover next? Where on Earth are you? Do you use GPS to navigate? If so, you're receiving information from the 29 GPS satellites orbiting Earth. The U.S. Air Force maintains these satellites. 24 satellites are active. The other 5 are backups. The satellites transmit radio signals to a GPS receiver in your phone or car. Signals from 4 or more satellites are needed to accurately determine your position. Digital maps are built into the receiver. They use the satellite's information to help you navigate.